Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so students, you all are doing really good. So students, in this video, we are going to learn about the projectile motion and the concept of angular momentum in projectile motion also. Okay, and this concept we used to learn under the chapter motion in a plane. Okay students, so let's start the video. This is the JEE 2024. Question is there, let's see please. A particle of mass m projected with a velocity u making an angle of 30 degree with the horizontal. The magnitude of angular momentum of the projectile about the point of projection when the particle is where at its maximum height h. So students, if in case the concept regarding this angular momentum is not clear, you can click on the I button, you can understand all the things. Okay, so let's start the video. So students, here please, here the projection velocity is u and making how much angle? 30 degree. Okay, and this I have taken here theta. Later I will put 30 degree. So what will happen that here at the highest point? Now this is called which point here? This is called the highest point. At the highest point, what will be there? This velocity will be how much? Only horizontal component u cos theta, that will be always constant. Vertical component of the velocity will only change from O to A, it will decrease, and A to B, it will increase. Which component? Vertical component, but the horizontal component always constant. So this is u cos theta. Now students, if I talk about here the angular momentum. So students, the concept is that, what is the concept? The concept is that angular momentum of the particle with respect to the any fixed point is given by P into R perpendicular. P is the line of action of momentum. R perpendicular is the perpendicular distance of line of action of momentum from the fixed point. And here in this question, the fixed point they have given at the origin here. Okay students, and if in case it is needed in a vector form also, in a vector form it used to be R cross P. Okay, with respect to the origin vector R. If some other general point is there, then this vector R will become delta R. Okay, so students, let's start this one here. So first one here. So students, here see please, angular momentum at A, that means highest point in angular momentum at A. Anyhow, with respect to this fixed point, with respect to O. Okay, angular momentum at A with respect to O, you can see very well. So first let me draw here the line of action of momentum. This is called what? Line of action of momentum. Just multiply with the m, velocity will become momentum. Very easy. So what I told right here, this is called line of action of momentum. LOA means line of action. Okay, so this is line of action of momentum and this is the perpendicular distance. Which distance? Perpendicular distance. Let's take OM. Can you see very well? This h and this h is similar. Okay, so students, here we can write here, see, this angular momentum at point A with respect to O is given by P. P means mu and here cos theta into what is h? You know the formula very well. U square sin square theta by 2g, or we can tell u sin theta whole square by 2g, like that. Used to remember that here. Okay, now we'll simplify this. What this will become here? M u into u square u cube by 2g into cos theta into sin square theta. Just put the value students. So mu cube by 2g cos theta. Cos 30 how much here? Root 3 by 2. Cos 30 root 3 by 2 into sin square theta. Sin 30 1 by 2, but square is there. That means it will become here how much? 1 by 4. That means when we will simplify this, it will come here root 3 mu cube by, see here please, 16g. Okay, so this is the answer for this question. Now students, if in case they ask angular momentum with respect to point O, or angular momentum at point O with respect to point O, or at point B with respect to point O. So in that situation also students, very basic thing I will just tell you. Here please, the second one. Fixed point is this only, okay. So now angular momentum at point B is given by, if they ask angular momentum at point B with respect to O. So you know very well here at point B, this velocity will be u, and you know very well this angle will be theta now here. Okay, so this will be how much here? U cos theta, and this will be how much here? U sin theta. Okay, now students, this is just extra we are doing here. This is called the range. This is called what? A range. So angular momentum at point B with respect to O is given by, this is the perpendicular velocity, how much here? U sin theta into R. Okay, just use the formula u sin theta into u square sine 2 theta by g, if in case they ask in an exam. Okay, so this one we have done here. If in case they ask angular momentum at O with respect to O, can you guess the answer? Yes, correct. The answer is 0, because the line of action of momentum, if you multiply with the m, is passing through the fixed point. Okay, so with respect to O, 0. With respect to A, this is the answer. With respect to B, this is the answer. All the concepts in a single video. Thank you so much.